Hey guys, welcome back. This is lesson 2 in unit 1, talking about segments, rays, parallel lines, and planes. It's a lot more of just laying out what terms are so we have more of a foundation for geometry. So let's start by talking about what a segment is. I've kind of starred a lot of our key terms for today. So a segment is a part of a line. Talked about lines last time. It's a part of a line consisting of two endpoints. Along with the two endpoints, it's all the points in between them. So we talked last time that a line is actually just a string of points that go on forever in either direction. So a segment just stops here and here, and it's all the points in between. So if I named all the segments on this line K here, I would have FG from here to here. The little line segment symbol above it. If you flip-flop that and say GF, that means the same thing. I also have GH, and then I have from F to H, so we'll call that FH. 3 line segments. Now, kind of a weird question, how many points are on line segment FH? Well, again, there's just like so many points in between those, and points, that was one of our undefined terms, a point. A point actually doesn't have a specific size, so technically there's infinite points in between F and H. Kind of a weird question. Okay, so that's a segment. The next term is a ray. Hoping these terms are semi-familiar to you, a ray is also a part of a line, but instead of having 2 endpoints, it just has 1. And then it's all the points going in either direction. So let me show you a picture. We'll call this point A. So say that that's like the one endpoint. And then maybe the ray is like the rest of the line going in that direction. So it's all the points extending forever and ever that way. They're going to name another point so you know the direction of your ray here. We'll get to that. There's also something called opposite rays. So opposite rays are 2 collinear, there's a term from last lesson. They're 2 collinear rays, which means they're on the same line, and they have the same endpoint. Okay. Note here, before I draw your picture, that opposite rays always form a line together. So here's my picture. Let's draw the same thing. A, B. So there's ray AB. Now, the ray opposite to this would have the same endpoint, so it would also start at A, but it would go in the opposite direction. Maybe we'll call that like AC. And notice together, AB and AC, they form a perfectly straight line. If it went this way, doesn't form a line, those would not be considered opposite rays. Okay, just like I mentioned last time, best way to learn is kind of to just jump into this and answer some questions. So here's a picture of 2 intersecting lines, and they're going to ask me 5 questions. The first one is name one ray with endpoint C. So here's C. And really I could use any of these other points to name a ray. Maybe I'll just go this way. So here's my ray. So it starts at C, and you've got to tell me what direction it goes in, so that's why you name another point. So I want to say it goes in the direction of F. So I'll call this ray CF. Note that you cannot flip this around. Rays are the only thing here where you can't flip-flop the letters, and it means the same thing. My answer, the endpoint is above C. So you're telling me it starts at C and it goes in the direction of F. Starting at F and going in the direction of C, that's a totally different ray. Okay, so do not flip-flop the letters if it's a ray. Number 2 says, are BD, ray BD, and ray BC the same ray? Okay, so BD, it starts at B, the endpoint's above B, the arrow's above D, so it goes in the direction of D. So there's ray BD. Ray BC starts at B, and it goes in the direction of C. So yes, those are the same rays. They've got the same endpoint. And they go in the same direction. All right, number 3, I'm going to ask you off to the side, so see what you think. Number 4 are CD, ray CD, and ray DB opposite rays. Using a lot of colors here. Ray CD, so it starts at C, goes in the direction of D. DB starts at D, goes in the direction of B. Now, 2 parts here. They've got to form a line. Those do. I just colored the whole line in yellow. But they have to have the same endpoint. They got to start at the same point. CD starts at C, DB starts at D. So this is a no. They have different endpoints. All right, number 5 are CB and CF opposite rays. There's CF, there's CB. So yeah, they've got the same endpoint. They both start at C, but they don't hold true with the second part of this thing. They do not form a line. They actually form an angle, which we have not gotten to yet. So nope. Okay, so that was kind of analyzing what happens when lines intersect. Rays happen, segments happen, all that good stuff. What about when lines do not intersect? Well, there's 2 types of lines that don't intersect. The difference lies whether the lines are on the same plane or not. Everybody knows what a parallel line is, or what parallel lines are. I hope at least. You do a lot in algebra with parallel lines. They're lines that don't cross, they're non-intersecting, and they're on the same plane, so we call them coplanar. You're going to be asked a lot about parallel lines here, and I think that is something that's going to be easier for you, which is good. It's skew lines that are new, and this is probably like the most challenging concept in today's lesson. So skew lines don't intersect, but they're not parallel because they're non-coplanar. So they are not on the same plane. Using roads is the best way to kind of explain this. So let me show you an example. If you use, I'm going to draw a rough little sketch here. So here's Kroger. That's kind of off of Scott Road. Illinois and Scott. So here's Illinois Road. I'll show you guys a picture tomorrow in class. So pictures, visuals always make a lot more sense. And we'll say that this is like Jefferson Point right here. Okay, Illinois Road. If you think about Illinois Road, that Jefferson Point and Kroger are off Illinois. Illinois intersects kind of with Highway 69. They don't intersect, but if you can think about where Illinois goes over Highway 69, there's a bridge here. And good thing too, because can you imagine if you're driving on Illinois Road and you have to physically cross over Highway 69, if they intersected, the accidents would be outrageous. So Illinois Road and Highway 69, they are a perfect example of skew lines. Okay, they do not intersect. You don't have to physically cross over 69 when you're on Illinois Road. They're also not on the same plane though. And I just think of planes like they're on different levels. Okay? Illinois Road goes over 69, so they don't intersect, and they're not on the same plane. They're thought of as skew lines. I'll show you a picture tomorrow. Realize that planes can also be non-intersecting, don't cross each other. There's no such thing as skew planes. If planes don't intersect, they're just going to be parallel planes, at least in our examples. So 2 examples to kind of finish this off here. See what you think. This is the kind of stuff you'll be asked tomorrow when we do practice problems. So first example, you've got this little prism here, technically what this is. Name all the lines that are parallel to CB. So what I do is I find the segment they're talking about. Parallel is just going to be all the pieces going in like the same direction. There's only one other one, and it's this guy, EF. Say FE, order doesn't matter for a segment. Number 2, name all the lines parallel to AD. Oh, these are different colors. So here's AD. Again, just think of the pieces going in the same direction. So CF and BE. Parallel hopefully is not too bad for you. Skew is where we're going to have to kind of think a little bit. Okay, here's what I think. All right, skew lines, they're not on the same plane. They're also not parallel. I kind of, in my mind, rule those two things out using process of elimination, and whatever's left, those are skew. So I'm going to highlight. I'm talking about BE. Now this is going to get messy. So all the ones that are parallel to BE, I just was looking at, so I'm going to highlight those. Those are obviously not skew to BE, because I don't want to talk about parallel. I also want to highlight all the segments that are on the same plane. So I'm doing process of elimination here. So BE is on the front of this prism, it's on that plane, and it's on the back of this prism. It's kind of like the top corner. It's on these two. It's like the point of the roof, really. So it's on these two planes. So anything I did not just highlight in yellow would be considered skew. So let's see if we can tell what I didn't highlight. I did not highlight AC and DF, and that's it. That's going to be the trickiest question you're asked. Okay, number 4, describe the intersection. So how do they meet? CF and ED. So CF is here, and ED is here. It's actually a trick question. Those don't intersect. They're skew. So like no intersection. Number 5, name a pair of parallel planes. So it's just planes that if you extended them, they would never touch. And the only option is like little triangles here. Those two guys are never going to cross each other. So I would just say like ABC and DEF. Okay, number 6, I'm going to ask you off to the side. And then let's jump down to look at the last example here. We saw this picture last time. It asked us a lot about lines and all that good stuff that we learned with planes and naming. So here's a few new questions. Name a plane, number 1, parallel to JAG. Okay, asking you this one off to the side. Number 2, name all the lines that are parallel to BC. It's the 3 segments going in the same direction. HI, GJ, AD. All right, here comes skew again. So name all the lines that are skew to BC. So again, I do process of elimination. I highlight the ones that are parallel, and I highlight the ones that are on the same plane. So what 2 sides of the box meet at BC? That's kind of what I think. Well, it's the right side and the front here. Those guys meet at BC. So anything I did not highlight would be considered skew. So GH, GA, JD, and JI. I think sometimes some people see that easier than others. It takes practice for some of us. Don't worry if that's you. All right, last question. Number 4, name all the lines parallel to, this is a plane, because it's 3 letters, plane GHA. So you got to figure out what side of the box is that. GHA, that's the top. So top and bottom are going to be parallel. So all the segments on the bottom of the plane are parallel to the top. So that would be JD, DC, CI, and JI. All right, that's lesson 2.